I think you're not required to know the mechanism, but the book just call our attention.
I just don't know how to draw out that final product, that method, because I didn't know how to do that today either.
I think one of the biggest things that, I mean, the first time that I took this class, that they just explained is just enols are never okay. Enols always have to change to something else because you just do not like enols, in 351 at least. But
I'm like, we have an enolate chapter just for that. Yeah, it's true. But I don't think you're required to. I don't know the reason why as well.
I think when she was actually talking about it in class, she says, we don't know why exactly this happens the way it does. It's one of those things that we still don't know why exactly it completely shifts that way and ends up with
We
a
just know
double
you could
bond.
have two products.
So there's nothing that like causes this alcohol to change to this.
Mm-mm. We're not sure how this enolate goes to this, you know, because some of the reactions, you're gonna see this in 352. They show you the reaction, they say this is happening in the lab, but we don't know the mechanism because it's under your head. So maybe one of you guys, when you decide to go to oral chem field, can say this is the mechanism for enolate for this reason.
That's for you to find out.
I'm going to another field.
He's like, screw that.
Well, I would like to go to organic, but I'm doing chemical engineering, so I don't think I'm gonna relate it with organic. Even though what I wanna do in my life is work with organic in petroleum, but yeah, I don't know. Maybe I'll become a professor one day, just for fun.
Clever gasoline.
It's true. I
I'll buy
accepted the blessing. Yeah, so this is the part that we do not know pretty well, the mechanism, so this is why we just memorize it. But I would say memorize the enolate mechanism reaction, how we got it to here. Because she gave it to you, it's like a 5-step reaction, and she probably gonna ask in the test.
As how did we got to where?
From the triple bond
Yeah.
to make your enolate.
Okay.
And she shows you in the board, right?
Yeah, she showed us.
So she's gonna probably ask.
What question was that one?
27. 27A, 27.
Just a whole bunch of synthesis stuff.
Yeah, we start now going to a point where we not that worry about the mechanism reactions, we start to worry about synthesis. So in your exam, more and more, you're gonna see more synthesis than really mechanism reactions. Maybe you should ask one question about draw the mechanism for this guy, but the whole exam, the multiple choice would be synthesize, 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 synthesize.
But you think this might be a mechanistic question? Could you go over that?
I can, I have my card. Never memorized this reaction. Well, where's my, oh, it's there.
Do you think this is something that we're going to actually have to show a mechanism for, or just the synthesis steps?
I think, I don't kind of, I have a, I don't know if it was in my quiz, but I remember she asking for us to draw the mechanism. I don't know if it was the quiz or the test.
Oh, fun.
It was in the quiz today.
It was not in the quiz today. But you also have chapter 7, 8, and 9, and I had on chapter 7 and 8, and chapter 9 and 10. So it was 2 exams that you have more space and room to ask more stuff.
Should we have done 7 and 8?
7, 8, and then 9 and 10. And then 11 and 13. And then final. We took the final on Tuesday, and, we did the exam 5 on Friday, and then the final Monday, and then the exam 5 on Tuesday. Something like that. It was like every single day one organic chemistry exam. Like,
One more
well,
lab. We only have one more lab too.
one more lab?
I think so.
No fun.
No fun the final lab? I know.
Well, then I won't need you to wake up.
Just
early.
kidding. We need your help.
No kidding.
So we have this.
And she decided to be nice to us, and she said that we don't need to draw in mercury when we're doing these.
You don't need to draw mercury. Yeah, she don't like mercury at all. She feels like it's carcinogenic, so I'm gonna make my students get that. I never memorized this mechanism, I don't know why. There's some on 352 that I couldn't. Even 2-3 steps, I'm like, I don't know why my brain doesn't accept it.
So the double bond gets added.
Wait.
To SN4.
Yeah,
Yeah, I was about to say that's the double bond.
I know.
You got a pentavalent carbon there.
Use the email.
So it's just water mechanisms basically the whole way across.
Yeah,
Because you end up with that alkyloxonium ion intermediate.
I think you can. You actually have a bunch of other products, but this is the two main importance that you want to emphasize. This one, or this is random structures. We're just using water over and over, and acid and water and acid.
Okay.
Is there supposed to be a double bond on that first carbocation?
Here?
Yeah.
No, because we use the double bond to grab this hydrogen. And then we make it water, so the hydrogen is here now, and we have a carbocation. So we break this bond. One electron goes here, the other one. You're just missing.
So, say that we had R or another group on the other side of that carbon, then we'd end up with what we had on the quiz today, and you would have two different mixtures of that and not just one, correct?
Okay.
Because you would have a double bond on that oxygen as well as, or the double bond on the oxygen on that carbon as well as the double bond on the other carbon
Yes.
as well. Okay.
And on here, just to answer your question, this lone pair here, don't seem there, making this resonance structure.
Okay.